Hi guys, hope you all are doing well. So I think today would be the sort of last video of this course for this section, which was elementary AI engineering. I won't call it elementary in true sense, but the idea is that we started with GitHub, we went on to doing continuous integration. I know we haven't done continuous deployment, but obviously once you would know a lot of things, you would do some projects. Later on, you can do continuous deployment. We'll do that as well. Then we have done Hugging Face, we have done prompt engineering, we have done RAG, and we have done AI automation using Python, and we have done an use case for AI automation using Power Apps as well. So now guys, I think we can now move to fine tuning. So guys, see, fine tuning is one of the important topics, but not very important as well to for beginners or starters. It's okay, you can skip it. There is no like a fight for it, but yeah, it's good to know fine tuning in an organization. If you would go, then only you can do fine tuning and all, and we all can discuss the use case, but we'll today discuss about the underlying ideas of fine tuning and what essentially happens. So see guys, as I said that you want your model to work on your private data. So one way was prompting, second way was RAG, and now the third way is fine tuning. So what we essentially do is we fine tune a model. Fine tune is a process of further training a pre-trained language models on a specific dataset for a particular task. Okay, this is fine. So essentially what we are doing is we are further training a pre-trained model on a specific dataset, so that essentially we usually change the weights. Okay, so what are weights and all? I think I'll have to make new slide. So see guys, a model consists of parameters. Okay, so if you have seen like there are models come up in this form. Okay, llama 3 405b. So what is 405? 405b is essentially 405 billion parameters. So if we change the parameters in specifically the last few layers of the neural network, that's essentially called as fine tuning. They are also mentioning, but in a different language. This, so essentially if you would retrain or essentially change the last few layers of the model so that the model can work on your task, it's essentially fine tuning. So I think fine tuning is not a new concept. Okay, yes, quantization and some compute related things also we'll discuss, but yeah, it's not a new concept. We used to do fine tuning especially in the time of CNNs and all. Okay, so you can, if you would just go to Google and you would type out, let's say you're working on an image classification task, so you can type I think Vision Transformer currently does great job at image classification, image fine tuning. See, fine tune, you can just open this. So you would learn on how to fine tune a uh, image classification task, and you would be fine tuning a VIT. That's just your transformer model. Okay, vision transformer model. So this is the model, and you can just see what they have also mentioned over here. And guys, see, fine tuning the code and everything is super easy. Okay, you don't need to do anything, you just need to copy paste and just have a folder structure in the way they want. Rest you can fine tune it. Fine tuning means changing the model's weight so that it can essentially work on your task. If you don't understand weights, just understand that there are few parameters in the models which you need to change so that the model can work onto your task. Now the thing is, I'll give you a use case. Okay, let me just pick up a pen. I'll give you a use case. Let's say your company has a lot of legal documents which are specific to your company. Okay, let's say you're a pharma company which has a lot of legal documents. Now you want an LLM to give some response based on your legal documents. So guys, see, the thing is that an LLM wouldn't know like what is uh, the legal documents of your company, so it needs context. So for that, option one is to pass the entire thing in a prompt, but the size is big. Second thing is RAG. Always guys start with RAG only. Okay, RAG is efficient, compute efficient, and also sometimes gives better results than fine tuning. The reason fine tuning is not done so much, there are two reasons for it. One is there are three reasons for it, I would say. One reason is availability of data. Okay, so guys, see, if data is not available in a particular format, fine tuning is not possible. Building a RAG is possible, but fine tuning is not possible. Second thing is cost. Okay, so if you fine tune a model, there would be a large cost involved, which would eventually be high compute. I'll talk about high compute as well. Okay, so we are doing good. Now, when should you go for fine tune? When you need a task specific performance. Okay, let's say, as I gave an example of medical and legal. So see guys, if you have more than thousand high quality examples, you can go for fine tuning. Start with RAG. If the performance is not good, try improving RAG, and then maybe you can start with fine tuning. Okay, otherwise they have just said that, hey, go for prompting, go for RAG. I think those are more essentially important methods. Now the thing is, let's just talk a bit about some stuff before moving into some practical demonstration of fine tuning a model. But I want to give you an idea of, hey, fine tuning is great, right? There's no problem in it. You're essentially changing few layers of the model, just retraining it a bit so that it understands your data a bit, which is good. Now the problem that comes is this part, that is the compute and cost considerations. Okay, so first of all, you require GPU, then you require particular data in a particular format. Even you can fine tune your model. You can even fine tune an OpenAI model, but the data needs to be in a very particular format. Okay, so if the data needs to be in a very particular format, then it becomes little difficult, because high availability of high quality data is not that easy. So now the thing is, guys, see, let's say, just imagine, like, for a 70 billion model parameter model, which is good, like it's not the best, but it has good performance on a lot of tasks. If you say decide that, hey, I'm going to fine tune it on a single node, that means a single machine, it would require about a machine of 256 GB RAM. Okay, so guys, just see, 256 GB, 1512 GB, these are not, I don't think commercial laptops come in these configurations as well. I don't think commercial laptops comes in these sort of configurations. So then the idea is that you would need to buy a server. So obviously most people and companies buy it from cloud. If you need something in house, then there are also a lot of like companies that do this stuff, so you can get that stuff. But I hope you're trying to get it right. See guys, availability of high quality data is a big task, cost is a big task, and stuff. Okay, it's not that simple. So now I'm going to walk you through an example of fine tuning llama 2 with QLoRa. So I think you won't understand QLoRa. See guys, there is something known as parameter efficient fine tuning, that is known as PEFT, parameter efficient fine tuning. What happens in that space is that researchers have come up with methods where you can decrease the precision of the weight. So what is precision of the weight? See guys, let's consider a floating point number 6.91351 or something, then you can decrease the precision 6.93, something on those lines, and hence therefore you can move ahead. So then there are things like QLoRa, LoRa. So basically guys, what are these are low rank adaptive methods. So I know these are some technical jargons, but it's just the fact that I think some of you might have read somewhere about rank of the matrix, decomposition of the matrix. It's just an efficient way to fine tune a model, because you will be playing around with the precision of weights and some mathematical decomposition, matrix decomposition, some math stuff that happens, that essentially lets you fine tune a model in a parameter efficient way. Obviously there is a drop in performance, but it's compute inexpensive. So now let me walk you through the code of how to do it. See, and as I said guys, fine tuning a model code is not difficult. RAG code is not difficult, but building an entire ecosystem might be a little difficult, which we'll see. Right now we are covering the ground. So on ground level, coding wise, generative AI is not difficult at all. So guys, you just need to load up the data set. So for this lecture purpose, I have used this data set. So this data set just consists of data in this form: instruction, input, output, and prompt. Okay, so this is just the data set format, nothing serious. Then guys, we are loading llama 2 model. Okay, now this is llama 2 model, and also now we are using bits and bytes configuration. So we are just setting up the configuration, guys. This is just quantization. Okay, as I said that quantization is the process of reducing precision of weights and activations in neural network. So you just need to use this snippet of code in order to set up your bits and bytes configuration, which will essentially set up your quantization data type, which is essentially the precision. Guys, keep it simple. Okay, all you need to be worried about is the precision of numbers. That's it. Then we are loading the pre-trained model. Then we are disabling the cache. If you want to read about every parameter and everything, you can read through it. And then we are tokenizing. I have talked a lot about tokenization. Then we are setting up LoRa parameters, and then we are just training it. Okay, rest all is simple. We are just normal training code. So guys, code wise this is not difficult. I think some of you might not be able to understand this LoRa and QLoRa because there is some mathematical instruction to it, which is based on matrix decomposition. But I'll tell you one way is that that's good to know. There's no problem in knowing, but for the time being you understand that hey, this is how fine tuning works. And essentially you have a code example in front of you, which is super easy to pick. The code is detailed, everything is talked about. You just need to follow along. And the next thing is, if you want to fine tune any model, you can just google for its code. Okay, like as I said, suppose you're training an image classification model, so you can fine tune, get the code and get it done. So that's all you need to do. There's nothing magical out there. Yes, knowing LoRa is a good thing to know, and you can search for articles and stuff. This is a little mathematical concept which works on mathematical decomposition and rank of matrix. So that's why I'm not covering it yet. But this is like good enough start for a beginner course. Now you understand that what fine tuning is, and you have an example in front of you. You can pick that example and learn it. It's just that it's very normal. And if you would remember that I have even given one lecture of fine tuning a classification model using BERT in my Hugging Face class as well. So I think this much knowledge for starters is enough. Rest, whenever you get a use case, guys, I'll tell you how to approach it. Okay, this is how you can learn. So let's say you are in an organization and you get a fine tuning use case. Okay, you realize that RAG is not working well, you need to fine tune a model. Okay, that's fine. So what you will do is you will first look for compute. Then based on the compute you would decide a model based on its size. Then you would load the model, and then you would fine tune it, and then you would deploy and use it. So essentially in this fine tuning you would be using these library bits and bytes just for the configuration, LoRa, QLoRa, and all these things you would be leveraging. So these are essentially just ways of reducing the precision of numbers so that we get the desired output but our cost and time gets reduced. Okay, that's the only thing to know as of now, and this is more than enough, guys. See, fine tuning, as I said, is an expensive task. A lot of people do some random experiments, they never work. Okay, there is no fun of fine tuning a 8 billion parameter on a Google Colab. Okay, that won't work. Even Google Colab doesn't support those kind of things. The compute is less. So just be aware about the compute and data quality considerations. And I'll tell you guys, see, let's say you want to find what would be the usual use case would be if you want to use fine tune an OpenAI based model. Okay, just type fine tune OpenAI. They have a section on fine tuning. Go to the documentation. So you would be fine tuning in GPT based model. Okay, just go through it. Just you need to prepare your data set in this format, that is role, system, content, and this is this is what is the I'll tell you, don't worry. Let me just copy one thing. Let's just copy this, let's just paste it. See, this is how role, system, content. So what is the system message, what is the question which user is asking, and what is the response which the model should give. All you need data is in this format, then you can just fine tune it. Okay, then you can just fine tune it. See, this is all the code that you need to use. They have given everything. Now the problem is, from where will you get data in this format? This is something people don't realize. Companies don't have data in this format. So would you manually do it? Maybe, maybe not. So that's the choice you would need to do it. Usually you would find, if you have a use case of fine tuning an open source model, then you can also do it, right? Just download it from Hugging Face and get it done. I can't show you the demo, as I said, that requires compute. Even I have a very, I have 16 GB RAM configuration. I brought the laptop with 8 GB, then I upgraded it to 16. But now I hope you're getting the idea, right? It's just simple that, hey, I'm gonna be just closing up, giving some closing thoughts. Let me just cancel it. Let me just take up an empty space. I'll just giving you some closing thoughts which are more than enough for any organization based use case. Okay, wait, I think this is not working. Notepad. So guys, see, the idea would be, people would come up to you and say that, hey, this is my data, I want an LLM to answer based on it. What you can recommend is, okay, this is very small data, we can pass it in prompt only. That idea is known as prompt engineering. Okay, no, this data set is big, we might need to convert it into vectors, store it into a vector DB, and then perhaps build a RAG system. We have discussed RAG as well. The third thing is, I have more than 1,000 records of very efficient, even guys, with thousands you won't get good accuracy. Let's say you have 10,000 records with high quality data sets, and then you can fine tune a model. You just need data in a particular format and you can run the code from internet. There is no magic. And then there are, as I said, right, people discuss about Q, LoRa and LoRa. So guys, see, these are just parameter efficient fine tuning techniques. Okay, if you want to go into the maths, you can check out any tutorial on YouTube. These are just based on matrix decomposition and the ranks of metrics. So this would be very technical, and as I've said that this is a beginner friendly course, it is mostly hands on. So we started out with GitHub, then we went on to continuous integration, then we discussed about prompt engineering, then we discussed about Hugging Face, then we have discussed about AI automation, then we have discussed about RAG, and now we have discussed about fine tuning. So guys, these are only the things that an AI engineer uses. Now how to move ahead? See guys, first thing is complete this course, ask your doubts to me personally, you can DM me into my LinkedIn, into my Instagram. Now the future would be that, start preparing for interviews. Okay, this much AI engineering section, this much knowledge is more than enough. No one is going to ask you anything more. Just be sure, I can give you an interview guide as well. Just be sure on studying the theoretical aspect of transformers. Just be sure of doing one project. Just be sure of doing one unique project, explaining it well. And also for interview purpose, just study about theoretical aspects of Q, LoRa and LoRa, and RAG as well, which I have taught. RAG I have covered mostly, Q, LoRa and LoRa remain, but those are mathematical things. Okay, you can learn from the internet. I don't want to go into the maths of the things too much because this is a beginner course. These are the type of questions you will be asked. No major question would be asked for 0 to 3 years in this space. Okay, if you are 3+ years of experience, then perhaps maybe you need to look at the architecture side of things. So yeah, that's also important. As this course and this channel would proceed, right, slowly we'll cover those things as well. But I wanted a course which is just for beginners, just pure English, just understanding what AI engineering is, what every fancy term is, and that's pretty much done. So thank you guys for staying in. You can DM me whatever you have. Okay, bye. Have a great day ahead.